Binomial refers to any expression that has two terms. For example, a plus b here, it has two terms. One of the terms is a and the other one is plus b. So that's a binomial. Then this 2p plus q is also another binomial because the terms are two. We have 2p and a q. So those are examples, a few examples of binomial. Now, if we have a binomial that we are supposed to expand, like we have x plus y squared, how do we work out that? Now, x plus y squared means x plus y times another x plus y. Now, if we split this bracket into its constituent terms and we maintain this one, we shall have that one being equal to this x into the whole of this. So we shall have x into x plus y plus this other term, which is y. So plus y into this, whatever that is in the bracket here. So plus y into x plus y. Now, x times x gives us x squared. X plus y gives us xy. Y times x gives us yx. And y times y gives us y squared. At this point, you realize we can write this ones alphabetically so that we shall have it change or interchanged to read as xy. Now the term will be, or this expression will be x squared plus xy plus xy. We have interchanged these ones so that we write them alphabetically, and they are now xy, then plus this y squared. At this point, you realize these are like terms which we can collect together. So we shall have this x squared maintained here, then plus xy plus xy. It's like this one has a constant 1 here, and this one also has a constant 1, such that 1xy plus 1xy will give us 2xy, and then plus y squared. So this is the expanded form of x plus y squared. Now you realize that the term, this is the first term, and the coefficient here is 1, because we know when a term does not have a coefficient indicated, we assume that it has a coefficient of 1. Here the coefficient is 2, positive 2, and the coefficient here is also positive 1, because we assume absence of a coefficient means the coefficient is 1. Now suppose we have another binomial, x plus y cubed, and we are supposed to expand it. We shall get x plus y cubed being equal to x plus y times another x plus y times another x plus y, as I've indicated here. But we have already done x plus y squared, and we expanded it to this form, which gave us this answer here. So you can simply take the whole of the second and the third bracket, we represent it with this answer here. So that we read x plus y into x squared plus 2xy plus y squared, which we already have here as the expanded form of x plus y squared. Now, as we did in the previous example up here, we split this first bracket as we maintain the second one. So this will be equal to x, this x, into the whole of this bracket, the second bracket, then plus y into the whole of this bracket again. We have split this first one as we maintain the second bracket. So x into the whole of the second bracket plus y into the whole of the second bracket. Then this times this will give us x cubed. This times this will give us 2x squared y. This times this will give us x y squared. Then this times this will give us y x squared. This times this will give us 2xy squared, is this one, and this times this will give us y cubed. The next thing is to rearrange these ones alphabetically. We shall have x cubed plus this one is written, it's already written in alphabetical order, so we take it 2x squared y plus xy squared plus, now this one needs to be written or to be rearranged alphabetically. We shall have it as x squared y. This is the one here. And then this one is already in alphabetical order, so plus 2xy squared plus y cubed, like that. The next thing is to put like terms together. This one does not have a partner, so we write it the way it is. We write it the way it is. This one we also write it, so plus 2x squared y. You realize that this x squared y has a partner, and that partner is this one here. It's also another like term. It resembles this one because it's also in terms of x squared y. So that's why I've put it here. Then we come to xy squared. This one is a like term to this one, so we write it down here after it, then plus y cubed. Now this one's in red. It's just to remind you that although their coefficients are not indicated, we know they have a coefficient of 1 in each case. So this one has coefficient 1, this one has coefficient of 1. Now let's simplify that. We shall have x cubed plus 2x squared y plus 1x squared y. These 2 plus 1 gives us 3x squared y. Then there is 1x squared, sorry, 1xy squared plus 2xy squared, giving us 3xy squared, and then plus this y cubed. So this is the simplified, or the expanded form of x plus y cubed. X plus y cubed, when expanded, can give us or gives us this as the answer. If we scrutinize it further, you realize the coefficient here is 1, the coefficient here is 3, the coefficient here is 3, the coefficient here is 1. Let's summarize the binomials that we have expanded and their answers that we have got. Now, this is what we have here. When we expanded x plus y squared, we got x squared plus 2xy plus y squared, which is here. Then we have just expanded x plus y cubed, this one here, and we have got this as the answer, which I've put down here. Now, if you expand x plus y raised to power 4, x plus y raised to power 4, you will get this one. This will be the answer. And x plus y raised to power 5, this will be the answer. Now, if we scrutinize the answers, you realize that the coefficient for x plus y raised to power 4 is 1, 4, 6, 4, and 1. And then the coefficients of x plus y raised to power 5 is 1, 5, 10, 10, 5, and then here it's 1. That's one thing we can learn. Another thing we can learn is that the power of this first term, the first term in this binomial, the power starts with a number which is equivalent to the power to which the binomial is raised. Like this one, x raised to power 5. You realize the power of the binomial was power 5. So it starts with that power to which the binomial is raised, and it keeps reducing by 1, because we have here x raised to power 5, x raised to power 4, x raised to power 3, x raised to power 2, x raised to power 1, and absence of x here means it is x raised to power 0, because we know anything raised to power 0 is 1. Now, as far as the second term is concerned, you realize that it starts from absence to y raised to power 1, y raised to power 2, y raised to power 3, y raised to power 4, and the last one is y raised to power 5. And you realize this power 5 is the same as the power to which the binomial was raised. I've said here y is absent. Why is it absent? Because it's actually y raised to power 0. And we know that anything raised to power 0 is 1. So that means actually y is here, but it's raised to power 0. And we know y raised to power 0 is 1. So it's like it disappears, because 1 times x raised to power 5 will remain x raised to power 5. The same pattern will happen here, or it will exhibit itself here. You realize the first term is x, the binomial is raised to power 4. So we shall start with x raised to power 4, x raised to power 3, x raised to power 2, x raised to power 1, and then x is absent, meaning it's like x raised to power 0. In terms of the second term, which is y, it's absent here, meaning it's like y raised to power 0, y raised to power 1, y raised to power 2, y raised to power 3, and y raised to power 4. I hope you know very well that when a term or a variable is written without a power, we assume the power is 1. That's why I said this is y raised to power 1. And of course, this is y raised to power 1 here. 2 is because the power to which this binomial is raised is 2. You will find it here. Now, read the numbers across. The numbers are 1, 2, 1. So these numbers correspond to the coefficients of the terms respectively. That means that it's like this binomial will have 3 terms. The first one will have a coefficient of 1. The second one will have a coefficient of 2, and the third one will have a coefficient of 1. Indeed, that's what is seen here because we have x squared plus 2xy plus y squared. Now the coefficient of this x squared is 1 because there's no number indicated besides it. That means the coefficient is 1, and that is the one that we have here. The next term, which is the second term, has a coefficient of 2, and that's what we have here. And the third one has a coefficient 1, that's what we have here. For this binomial raised to power 3, you will have to look for 3 along this line, and that is here. So the terms, it is like that binomial when expanded will have 4 terms, 1, 2, 3, 4. The first term will have this as the coefficient. This is for the second term, the coefficient for the third term, and the coefficient for the fourth term. And indeed, if you look at this, we have the coefficients 1, 3, 3, 1, and that's what we have here. Similarly, for x plus y raised to power 4, the coefficients are 1, 4, 6, 4, 1, and that's what we have here as 1, 4, 6, 4, 1. So that's how we use a Pascal's triangle. Now, back to our business. How do we write a binomial, or how do we expand a binomial using Pascal's triangle? So the first step is to identify the coefficients of the terms from the Pascal's triangle, as I've shown you. After that, you write the terms using descending powers of the first term of the binomial and ascending powers of the second term of the binomial. What I mean by descending powers of the binomial is what I told you a few minutes ago, that if you look at this x here, which is the first term in the binomial, it starts with a power corresponding to the power of the binomial to which it is raised, to which the binomial is raised, and it keeps reducing by 1. So it is descending from x raised to power 5 to x raised to power 4, 3, 2, 1, and 0. So this is like x raised to power 0. Then for the second term of the binomial, it starts from 0 and it keeps ascending up to the power which will correspond to the power to which the binomial is raised. So here it's like y raised to power 0, y raised to power 1, y raised to power 2, 3, 4, and y raised to power 5. So that's what I mean when I say that you write the terms using descending powers of the first term of the binomial and ascending powers of the second term of the binomial. So if we consider the binomial we had, which was x plus y cubed, and we expand it using this procedure, then the first thing is to come up with a table which summarizes that. So we shall have a table like this. Remember, this table is not a must, but it's just for the sake of illustration. As you continue working more questions on the same, you can do it without the use of this table. Now, we are expanding a plus b cubed, in other words, raised to power 3. So we come up here to our binomial, and look for where 3 is along this line. 3 is here, meaning the coefficients are 1, 3, 3, and 1. So that's where I've got my 1, 3, 3, and 1. Then the second row here, I've just come up with the terms A and B from the fact that this binomial has A and B and as the terms. So this one will start with the power 3, and it will keep reducing the power by 1 with in each subsequent term. So we shall have A raised to power 3, A raised to power 2, A raised to power 1, A raised to power 0. For this one, it will start from B raised to power 0 up to B raised to power 3. So we shall have B raised to power 0, B raised to power 1, B raised to power 2, B raised to power 3. So these are the ones that we shall use in expanding. Therefore, we shall say A plus B cubed is equal to this one times this. So we have 1A cubed B raised to power 0 plus 3 times this. So 3A squared B raised to power 1 plus this 3 times this. So plus 3AB squared. Then plus 1 times this. So 1A0B cubed. Notice that I've used different colors here so that we can track the terms that we are talking about. So at this point, of course, you realize that we have terms which have power 1, and therefore we don't necessarily have to show those powers like this one. So that's why I've written it as 1A cubed. Remember, B raised to power 0 is 1. So 1A cubed times 1. That will give us 1A cubed. Then plus 3A squared B raised to power 1. But remember, B raised to power 1 can be written as B. We don't have to indicate the power. Then plus 3AB squared. Then plus 1 times A raised to power 0 is 1 times B cubed. So this is like 1 times B cubed, because this is 1 times B cubed, and that's 1 times B cubed. That's what we have. So that is the answer that we have. Of course, here I've ignored the fact that I don't have to write this one, since we know A cubed means it has a coefficient of 1 here, and I don't have to indicate this raised to power 1, because we know if we have A indicated alone like that, the power is 1. So this one is just the same as what we had found up here initially. When we expanded, that's what we had here. To expand 3x minus 2y raised to power 5, use the same procedure, come up with a table. The Pascal's coefficients are 1, 5, 10, 10, 5, and 1. And then for this one, you split it into the respective terms. For 3x, you write it in descending powers from 5. Then for negative 2y, you write it in ascending powers from 0 to 5. So that's why we have 3x raised to power 5, raised to power 4, raised to power 3, raised to power 2, raised to power 1, and raised to power 0. And then negative 2y raised to power 0, 1, 2, 3, 4, and then 5. After that, we now write the expanded form. We shall say 3x minus 2y is equal 3x minus 2y raised to power 5 is equal to this times this. So 1 times this plus 5 times this plus 10 times this plus 10 times this plus 5 times this, and then plus 1 times that. Now the next thing is to simplify. We realize we have 3 raised to power 5, which we need to simplify. We have 3 raised to power 4 and such like so. That will simplify to 1 times 3 raised to power 5 gives us 243, then x raised to power 5, and then times 1, because anything raised to power 0 is 1. Then 5 times 3 raised to power 4 gives us 81, times negative 2 raised to power 1 is negative 2, then y raised to power 1 is y. Then plus 10 times 3 cubed is 27, then minus 2 squared is 4. So we shall have that term. Then for this we shall have 10 times 3 squared gives us 9. X squared is x squared, minus 2 cubed will give us minus 8, then y cubed. And then this one will give us 5 times 3x, then negative 2 raised to power 4 will give us 16, then y raised to power 4 will give us y raised to power 4 like that, then plus 1 times 1 times 2, negative 2 raised to power 5, y raised to power 5 giving us that. Now if you simplify that, then you will get 243 times 1 giving us 243x raised to power 5. 5 times 81 times negative 2 giving us negative 810 x raised to power 4 y. Then 10 times 27 times 4 giving us 1080 x cubed y squared. Then 10 times 9 times negative 8 giving us negative 720 x squared y cubed. Then this will be 5 times 3 times 16 giving us 240 xy4, and then 1 times negative 32 giving us negative 32 y raised to power 5.